Hey there, 8th grade. We're now talking about what I consider the cornerstone of the basics of algebra, or especially the new material that comes up in algebra, and that's using the coordinate plane to graph. And so we graph relationships on the coordinate plane, and we end up using it a lot. And so it's really important to have this sort of thing down. We've dealt with a decent amount of it before, but there's a number of new notes in this video, and it's going to seem like a lot, but you'll get through it. So here we go. A function is a relationship between a set of inputs, which is the independent variable, that's the one that we change independently on its own, it changes, and a set of outputs. So a function just basically is, and it looks like an equation, it's just where we throw in one variable, we throw in one value for a variable, and then it spits out an output, it spits out a value for a different variable. So that's what a function is. But there's also a few more details about the function we need to know. And that's number one, we commonly use x as the independent variable, so that's the one that we change more freely on its own. That's the input. Two, we commonly use y or f of x, function based on x, as the dependent variable for outputs, so that's what we're usually solving for. And then the last part is that for it to be considered a function instead of a normal or any other relationship, every input x, every time you put in an x value, you can only get one output. So if we put in 5 one time and it gives us 7, then every time we put in 5, we better get 7 out. We better not get anything else. Next set of notes are that we can graph functions and relationships, even if they're not functions, on the coordinate plane by using xy charts. And that's what we're going to do a lot in this video, is we're going to use xy charts to see what the graphs of different functions look like. How do you use an XY chart? Well, you just make an X column, a Y column, and you choose whatever X's you want, and you see what Y's the function or the relationship spits out. What is the Y that matches up and makes an equation true when you put in that specific X? On the coordinate plane, functions always pass the vertical line test. So we can look at functions, we can look at an equation and try and decide if it's a function, but the graphing really helps us, because if we know that whenever we put in an x, we get out one and only one specific y, then if you're ever going to draw a vertical line on the graph, and we'll see this, it should only, at a specific x is where the vertical line would start, then it better only hit the line in one spot. Because at that x value, we should only have one y that we get out of the function. So if you draw a vertical line at a given x point and you get two different y's that you hit on your graph, that means that we don't have a function. The last one is that when we're graphing, the scale on the x-axis needs to be constant, and the scale on the y-axis needs to be constant, but they can be different from each other. So sometimes we're using values that are really big, and a lot of people are used to using hash marks that are equivalent to 1. Each hash mark is worth 1. Well, if you're trying to graph the point 27,350, you don't have graph paper big enough. So we can change the scale as long as every hash mark increases by the same amount. So in that case, we would probably, for the y, if it went up to 327 or 350 or whatever I said, we would probably go by 50s. And so we'd only have to go up 7 hash marks. So another way to say this is that every next hash mark changes the same amount. That's what it means if the scale is constant. All right, we're going to get into some practice problems, but first I just want to make sure we review what we already know about the coordinate plane. So this is called the coordinate plane. I'm going to ask you to draw this and label a few parts with me. We know that this is the x-axis. And I like to think that x is like a short and a fat number, or it's not a number sometimes. It's a letter. And this is the y-axis, and y goes more up and down. So that kind of makes sense that the y-axis goes up and down. Now what else do we have? Well, we have this central point. This is called the origin. And so we should list that. This is the origin. And we usually put a 0 right there because it starts at 0 no matter what your scale is. Then we have 4 different quadrants. This is quadrant 1, quadrant 2, quadrant starts with quad, which you should be familiar with hopefully. You can think of a few other words that start with quad and mean 4. And this is quadrant 4. We use Roman numerals for those. Finally, we plot coordinate pairs. And if our scale on the y and the x-axis is 1, then we need to know that we run before we rise to name them. So we ran 4 to the right would be positive, 2 up would be positive, so that'd be positive 4, positive 2. And that's called an XY pair or an ordered pair or a coordinate pair. whichever you like. So that's just a coordinate plane review. Let's see how we're going to use it. So let's get to work. Number 1 says graph the following relationship and see if it's a function. So this is what we're going to see what the XY charts really look like, because we're going to graph it using an XY chart. So I'm going to just make an X column and a Y column, and I'm going to choose whatever X's I want. And I usually like to choose about 5. And I start, if it looks like it'll work, with some basic numbers. And now for these X's, I can plug in them right into the equation. I'll put in these numbers for X, and I'll see what is the Y equal to when the X is negative 2. So negative 2 to the third power means negative 2 times negative 2 times negative 2. That'd be negative 2 times negative 2 is positive 4 times negative 2 is negative 8. Negative 8 times 2 is negative 16. Negative 16 minus 9 is negative 25. Negative 1 to the third power. Negative times a negative is a positive, so that'd be positive 1. Times the third negative 1 would make us back to negative 1. Negative 1 times 2 is negative 2. Minus 9 is negative 11. 0 to the third power is 0. If you're multiplying 3 zeros, it'll be 0. 0 times 2 is 0. Minus 9. 0 minus 9 is negative 9. 1 to the third power is 1, because if you multiply 3 ones, you get 1. 1 times 2 is 2. Minus 9 is negative 7. And 2 to the third power, 2 times 2 times 2 is 8. Times 2 is 16. 16 minus 9 is positive 7. So there we go. Now, the great thing about XY charts is we already have 5 ordered pairs to plot. And we know how to plot. We run, then we rise. And I can just name my scale now that I know what sort of points I have to plot. So I know that my Y goes all the way down to negative 25, and I have 10 hash marks here. So I know that we'll probably have to go by something like 3. Now, but we're only going up, our X's only go up to 2, so let's just go by 1 there. Now, negative 2, 1, 2 to the left, we run first, negative 2 is to the left, negative 25, negative 3, 6, 9, 12, 15, 18, 21, 24, so negative 25 would be about there. Negative 1, negative 11, negative 1, 3, 6, 9, 10, 11, not quite at negative 12. 0, negative 9, 3, 6, 9, right there. 1, negative 7, 3, 6, 7 would just be a little bit below negative 6. 1, negative 7, we just did that. 2, 7, so 2, and then we'll go up 3, 6, and a little bit more is 7. Now, I'm going to connect these, and I know that we're going from left to right. Our X is increasing, so it looks like it flattens out, but then it gets pretty vertical again. So this is what our graph looks like. Is this a function? Well, if I draw any vertical line, I would only hit one point on the line. I wouldn't hit 2 different points. And you can see as we put in X values, we're only going to get one Y out whenever we put any X values. So we'll say yes, it's a function. Let's look at another one. Make sure you have that graphed and written, the XY chart. This next one, they already gave us the XY chart. They gave us the, what is this? They gave us the XY chart. They gave us the coordinate pairs. But we need to think of, okay, what's going to be a good scale for this one? Well, I know my Y's go all the way to 600. Just go by 100 each hash mark, and that way we'll get all the way to 1,000. We won't use it quite all. My X's go up to 20, though. And I have 10 hashes, so we could go by 2. We could go by 4 or 5 would be good as well. We could go by 10 even if we wanted, but let's go by 4. I'll hopefully space it out a little bit. So negative 20 would be 5 hash marks to the left, because 4, 8, 12, 16, 20. Negative 600 would be down. Did I go 5? 1, 2, 3, 4, 5. Negative 100, 200, 300, 400, 500. 600, so that's negative 20, negative 600. Negative 10 would be negative, maybe I shouldn't have chosen this. Maybe I should have gone by 5s. It's okay. Negative 4, negative 8, halfway in between. And then we have to go down to negative 100, which is just 1 hash mark below. Next we have 0, 400. So it's 0, running 0, then going up positive 400. That's our rise. We run, then we rise. 10, negative 100. 10 would be 4, 8, and halfway to the right. Halfway between the second and third would be halfway between 8 and 12, which is 10. And then down 100 is negative 100. And 20 again would be 5 to the right this time since it's positive, and we'll go down to negative 600. So what we see is this is actually looking like it's pretty sharp. But this looks like a function because, again, we're not having any vertical lines that hit two or more spaces of our graph. And it seems like for every x value we put in, we get only one y out. So this is another function. So we'll put, again, yes, this is actually what an absolute value function looks like. That sharp point which it bends back down. So to have a negative coefficient. Okay, let's do one more together and then I'll set you loose on your own. This one says, determine if the following is a function, and again, they're going to make us make the XY chart. That's okay. We like XY charts. Now I'm going to start something off, and I want you to see the problem we might run into. So we could plug in x's, but this time it actually might be easier to plug in y's. So what if we plug in like, and I'm going to change this, sorry, so change this with me. Change it to negative, or minus 500. It's not the biggest deal in the world, and we could do it either way, but I'm just going to like it more that way, I think. So let's pretend, let's not pretend, let's just do it. Let's put in y's first and see what the problem is here. So what if we do negative 2, negative 1, 0, 1, 2. I'm going to like some of these, not all of them. Negative 2 squared, negative 2 times negative 2 is 4. 4 minus 500 is negative 496. Now if you're thinking about this, when we put in 2 for y, 2 squared also equals 4, so we get the same thing back here, 496. When we put in 0 for y, we get negative 500. Put in 1 for y, or negative 1, it'd be 1 squared, which would be 1 minus 500 is negative 499. Now this isn't going to be great, and I want you to look at this with me. If we go negative 496 and down 2, okay, well I would have to be making my x scale would have to be like 100 or 50 to get us all the way back to negative 500. But then we wouldn't move much right and left because the only other x's we have are negative 499 and negative 496. So we'd be pretty vertical. We'd be hugging things really closely. We wouldn't be using all of our graphs. So in this case, I'm actually going to use different values rather than just negative 1, negative 2, 1, 2, and 0. In this case, let's try and use some other ones that we know how to square pretty easily. So let's do this. Let's see what happens if we use something like negative 20, negative 10. Oh, I'm in the wrong spot. We're using y's first too because this is a weird looking equation, right? It seems easier to plug in for y than for x. So for our y's, let's see what x's would give us an output of negative 20. And I know it sounds weird because we're actually putting these in, but you gotta do what you gotta do sometimes. 10 and 20. That's really messy, but I'm wasting a lot of time. Goodness gracious. Okay, so if we put in negative 20 for y, what was the x that gave us that output, that y value? So negative 20 squared would be 400, because negative 20 times negative 20 is a positive. 400 minus 500 is negative 100. Same thing for positive 20. So that would also give us negative 100. Negative 10 squared is 100. 100 minus 500 is negative 400. 0 minus 500 is negative 500. 0 squared is 0. And 10 squared is 100 minus 500 is negative 400. So this is going to spread us out a little bit more. We're still going to be on one side of the graph, but that's okay. So our x's go all the way back to negative 500. So let's say our x increases by 50 each time. And our y's, let's say those increase by 5 each time. So this first one is negative 120. So negative 100 would be 2 to the left, 5, 10, 15, 20. Negative 120. Second one, negative 400, negative 10. So negative 400 would be negative 50, negative 100, negative 150, 200, 250, 300, 350, 400. Negative 400, negative 10. I'm so bad. I put this in the wrong spot, didn't I? I should have been negative 20, which is down here. Don't make mistakes like me. Next one, negative 500, 0. So if each of these is 50, then we have to go 10 to the left. Negative 500 and 0 is our rise, so we don't rise at all. And now we just have kind of mirrored points. Negative 400, now positive 10. Oh, I guess I could have left it. Negative 100, positive 20. So what is this one going to look like? It looks like it's curving a little bit. But this is what it looks like. Now, is this a function? No, because when we put in negative 400 for x, we could get out y's of negative 10 or positive 10. This does not pass the vertical line test because the vertical line hits the graph twice. So this is not a function. Now I'm going to finally let you get loose on some of your own. So here we go. Let's check out what I got in store for you. I want you to graph these both, and you should probably use graph paper, and tell if they're functions. Use XY charts for the first, and the second one it's already given to you. So first graph it, then tell me if it's a function. You made it through probably the longest video of the year. You're the best. I'll see you soon.